So this is the first question, which is based on what we learned so far. And in this question also, you'll be able to see the power of pre-analysis, how doing pre-analysis can help us find the answer very easily and within 2 minutes. So let's start by actively reading the question stem. It's given that x and y are positive integers. Okay, so it makes sense to write down all the information x, y, positive integers. Now you're given an expression which is x plus 2 to the power y plus 2 plus x to the power y times y minus 2 to the power x plus 2, and you need to find out whether this is even or not. Okay, now once again, a lot of you might want to jump to the statements and try and find out what is x, what is y, but it makes sense to do the pre-analysis and see if we can figure out when is this even expression even and when is this odd. And to do that, what you need to do is basically consider the cases, all possible cases. So what you basically do is you take x and y, okay, and you think of the scenarios, possible scenarios that can happen. One scenario is when both of them are even, right? Just one sec. Let me just rub this quickly. Okay, yeah. So one scenario is when both of them are even. One scenario is when both of them are odd. One scenario is when this is even, this is odd, and one scenario is when this is odd, this is even. So let's see in all these 4 scenarios, what do we get as the final answer for this expression? Now, if both of them are even, well, it's quite obvious that even plus even to the power even plus even will be even, and even to the power even by even minus even to the power even plus even will ultimately give you even, right? When both of them are odd, let's see what happens. Odd plus even to the power odd plus even, odd to the power odd, odd minus even to the power odd plus even. Now odd plus even will give you odd, and odd to the power anything is also odd. Similarly, odd to the power is odd, and odd minus even is odd, so you'll get odd here also, and odd plus odd is even. So notice that in 2 scenarios you're getting even. When both are even, then also you get even. When both are odd, then also you get odd. Now let's take the third case, when x is even. When x is even, you'll get even plus even to the power even, odd plus even. Here you'll get even to the power odd, and odd minus even by even plus even. Now notice even plus even is even, and even to power anything is always even. Here even to the power odd is even, this is even, and even multiplied with anything will also be even. So you don't need to check anything, you can simply say this is even, so this is also even. So notice even in this case you are getting even. So in 3 cases you're getting even. Now let's check the last case. And in the last case, notice that if you take odd plus even to the power even plus even, okay, and here you'll get odd to the power even by even minus even to the power odd plus even. Okay, now even plus odd is odd, right? And here you have even minus even, so this is even, and even multiplied with anything will obviously be even, so I can say this is even. So let me write that down, that this is even, and here you are getting odd. So notice only when x is odd and y is even, in that case you're getting odd. In rest of the other cases you're always getting even. Now this might take you about 1 minute, 1.5 minutes to write this down, depending on how good are you with your even and odd. But with this in hand, you'll be easily able to do your inference when you're looking at each and every statement. Okay, so let's take the first statement and see what we can do with it. Okay, let's go to the second step and look at statement 1. Statement 1 is 5x plus 8x square plus 12x cube plus 9 is odd. So let me write it like this, is equal to odd. Now I don't know what 5 is, but I can write 5 as odd. I don't know what x is, but I know what 5 is, so I'll write odd times x. Now 8 is even. So even multiplied with any integer will always give you even. So 8x square is always even. Similarly, 12x cube, 12 is an even number. Even multiplied with any integer is even. So this is also even. And this is odd. And this is odd. So notice you're getting odd times x is equal to, this is odd minus even plus even is even, which ends up giving you odd times x is equal to even. Now think about it. You're multiplying an odd number with x, okay, and you're getting even. When is this possible? This is only possible when x is even, right? Then only even times odd will give you even. So from this statement, you can figure out that x is even. Okay, so if x is even, you're looking at this case and you're looking at this case, right? Now, most of you who do not do a pre-analysis may think, hey, statement 1 is not sufficient, so let me discard it. But now look at both these scenarios. When x is even, in both these cases, it does not matter what y is, because in both the cases, you'll end up getting even only. So if x is even, you can confidently say that the given expression is definitely even. So this statement is sufficient. So your answer cannot be B, your answer cannot be C, you cannot answer be E, it has to be either A or D. So those of you who ended up marking the answer as C, you made the mistake of not doing a pre-analysis. Now let's look at the next statement very quickly. Now the second statement is 3y, again I'm writing it directly, 3y means odd times y, plus 11 plus y. So I'll write it like this, I'll say odd plus y, okay? Or in fact what you can do is, you can take 3y and y, okay, and write it as 4y. Let me rub this so that you can see what I'm doing. Plus 11, which is odd, so I can write this as odd, okay. Now 35 times 3 would give you 105y, plus 35 times 2 is 70, and this is even, okay. Now notice 4y is even because it is multiplied by 4, so it does not matter what y is. So this is even. We already have odd. I don't know what y is, so I'll write this as odd times y. This is even, and obviously this is also even. So odd times y comes out to be even minus even minus even minus odd, which ultimately gives you odd times y is equal to odd. Now the product of two numbers is odd, and that is only possible when y is odd, right? Then only you'll get odd. Now think about it. If y is odd, can you get your answer? That is what you need to ask yourself. Now you'll check these statements. Now see, if y is odd, these are the two cases, right? And notice when y is odd, it does not matter what x is, because in that scenario also you'll get even. Okay, y is odd, x does not matter what it is, it turns out to be even. So even this statement is actually sufficient to answer your question. Because using this statement also you can say irrespective of what x is, the answer has to be even. Hence, the correct answer in this case is option D. And I hope now you'll appreciate why you need to do pre-analysis. If you do not do pre-analysis, what most of the students will end up doing is they'll find x is even from this statement, y is odd from this statement, and then they will plug these two into the expression to find out the answer, which is incorrect. You don't need to do that. Okay, so I hope this is perfectly clear. In case you have any doubts, please feel free to us. Okay.